All right, so before you do the end of week form, I wanted to make sure that we'd gone through these practice problems here because it's important that you not only know what side, side, side is, but you understand how to look for that in a pair of triangles. So let's focus in here on this top right example, which we would have done in class today if we had been able to finish the practice. So it's given that R is the midpoint of segment PT and that angle P is congruent to angle T. All right, so they've shown us that. They've also shown us that angle PQR is congruent to angle TRS. So they've given us two angles. Now I'm just going to think about all of the ways that I can prove that two triangles are congruent and figure out which of these is going to be useful to me here. Side, side, side probably not going to help me. I've been given two angles, so I probably want to use one of the congruence postulates that uses two angles. Now the question is, should I apply angle, angle, side, which would require me to know this side here, or if not that side, but this side here? Or should I apply angle, side, angle, which would require me to know the side in between the two angles that I know? And I think this is going to be the easier thing to show, and I can figure this out based on what they gave me. They said R is the midpoint of PT. So if I were to do a proof, I would be able to claim next that segment PR is congruent to segment TR because that's the definition of a midpoint. It creates two congruent line segments. And so now you can see that I've got an angle, and I've got a side, and I've got an angle that we're showing are congruent to an angle, a side, and an angle. So here, what we would be using is the angle, side, angle postulate to prove that triangle PQR is congruent to triangle TR or TSR. All right, so this is what we're looking for here. Figure out which postulate we would need to use in each of these cases. So take a look at this and think about our postulates. Okay, well, we've been given a side here that's congruent to a side there. We've been given another side here that's congruent to another side there. So we're probably going to pick a postulate that uses two sides because we've been told that two sides are congruent. And now the question is, if I'm going to use side, angle, side, should I try to show that these two angles, the angles between the two sides, are congruent? Or should I show that the third side of each triangle is congruent? And that's the way that we're going to go. We're not going to be able to show that those two angles are congruent because we don't have enough information here. But if n is the midpoint of MO, then again, that's going to mean that these two sides are congruent. And so therefore, I would be able to use side, side, side to prove that triangle LMN is congruent to triangle PON. So the answer to that one would be side, side, side. Okay, let's keep going here. Side, 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 angle, angle, side, angle, side, angle. Those are my only options at this point. So what do we know? Well, we know that A is congruent to E, so I'm going to probably use an angle. And then they told us that AE bisects BD. So this segment here is being bisected, which means it's being cut in half. So it's going to create two congruent line segments, which is going to allow me to claim that those two segments are congruent. So if I were doing a proof, I would make the claim that segment DC is congruent to segment BC. And so I'm going to use a side here. So I have an angle and I have a side, and now I need to figure out what other piece of information I can determine from this diagram. Remember that vertical angles are congruent. You don't need parallel lines or anything like that. Anytime I have vertical angles, I can claim that they are congruent. So I've got two angles and one side. Now I need to determine which of these postulates I'm actually applying here. And this is where order matters. If I had determined that this side was congruent to that side, which I didn't do, but if I had done that, then I would have had an angle, a side, and an angle in that order. I only use ASA if the side is sandwiched right in between the two angles that you've proven are congruent. But that's not what we've got here. We've got an angle, and then an angle, and then a side. An angle, and then an angle, and then a side. So it's angle, angle, side in this case. And that would allow me to say that triangle DCE is congruent to triangle BCA. All right. A couple more here that are a little bit tricky. So here you're given that you have a segment PQ congruent to segment RS. All right, so if I'm thinking about all the options I have here, I already know I'm probably going to be using something with a side, which they all contain a side, so that's not super helpful. Okay, but then they tell me that I've got two angles that are congruent. All right, so that sort of rules out side, side, side. Doesn't always have to mean that. Maybe I will have enough information to find all three sides, but here they're giving me an angle. It's likely that I'm probably going to use it. So then I have to figure out what other information is out there for me to discover. I don't have anything that's going to allow me to say that these two sides are congruent, so I'm not going to be able to go, get that piece of information. I don't think I'll be able to find this. They haven't told me anything about this shape as a whole. Like, is it a parallelogram or anything like that? We don't know. So I can't make that claim. I'm not going to be able to say angle, angle, side here. But this side here is interesting. Because in triangle PQS, that's a side. That's side QS. In triangle RSQ, that's side SQ. And if I can show that those two sides are congruent to each other, well, then I'll have side, angle, side. So I would be able to say, actually, that these two sides are congruent because they happen to be the same segment. So I have enough information here to make the claim using side, angle, side to say that triangle PQS is congruent to triangle RSQ. And in a proof, I would use the reflexive property to claim that this side is congruent to this side because they actually are the same segment. And so we have a similar situation in this next example here. Think about all the ways that you can prove that two triangles are congruent. If L is congruent to N, and if LO M is congruent to NMO, we have to find some other piece of information that we can use here. And again, that piece of information is going to be that shared side, which is going to allow me to use angle, angle, side. Not angle, side, angle. If it were angle, side, angle, that would be the side I would know. But angle, angle, side here. Therefore, triangle LMO is congruent to triangle NOM. All right? So just a few examples, seeing those triangle congruence postulates used to come to the conclusion that we have two congruent triangles. And we'll discuss this one here on Monday, but I did want you to see those before you do that end of week form.